This will be part 8 in the series Science of the Symbols, and a bit of a departure because I'll end with a geometry instructional, but it does carry through with the same themes of the last episodes and for the moment, measurements. Now, I wanted to stay more with pure symbolism, but invariably in Hermeticism, you're always really important to go to measure systems. Hermes, god of weights and measures, both same sort of thing. But so we measure length, time, weight, temperature, even pressure, but the 360-degree compass here will be an important one. And we're doing a straight edge compass and straight edge construction. Now, been focusing on this drawing by Kircher and been touched on Albrecht Durer, or Durer, I'm not sure, but this is his construction to get a close approximate of the Nonagon, the 9-sided polygon of a 9-pointed star. And that's what we see here, the 9-pointed star. Now, I will put a link in the description because this is a very cool short PDF introduction to the work of Albrecht Durer, geometry, maths, as well as even, really clever guy, did a lot of amazing work way back when. And so again, compass and straight edge. And so, for instance, on the books of measurement, so geometry, geo, earth, metry, measure. So geometry, measurement, Hermeticism, and all of these, it's hard to separate, or really impossible to separate, because it also connects to the Quadrivium, music, astronomy, geometry, and arithmetic. These things all actually blend together, this part of his ancient science. Now, I'll put this link in the description because you can get the names and then move off onto, if you're interested into more of his larger text. But yeah, so Albrecht Durer. Now, this is his construction approximate of how to draw a 9-sided polygon, 9-sided shape, or a 9-pointed star, either way, just like a pentagram or a pentagon. It's from the same construction, and how this connects to Kircher up here. Back in 2013, I did an instructional on how to draw using Durer's method, and while I was doing that, I'm just making some graphics, and I just try to, I overlaid it on the sacred geometry of a fruit, seed, and flower of life, and I noticed, it pops out. It's actually very cool stuff in there. I had a look, I couldn't really find it published anywhere at the time. However, looking further into Kircher, I think that this construction, which I sort of thought was my own, or at least I come across it independently, maybe it was published before, but I think it's actually hinting at it. So the 9-pointed star, and I'll show you what I mean. Now, I'll also put a link in the description to Geek 37. He's done more than a few Nonagon videos, and this link here is to one. So he come across my video and he found a simplified way of doing it. So instead of filling it out with all those circles, you don't need to do those circles. And at the end, I'll be doing showing you with geometry like compass and straight edge how to do this. So if you're not on GeoGebra and not familiar with CAD and this type of stuff, I think it's much, when you do it with the pen and the straight edge and the compass, so it's very therapeutic, meditational in a way as well. But also I think it adds a layer to it, like you're closer to it in that sense. But this construction will lead us to this drawing here. And so there we see, just a close-up of it. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, with this triangle and the all-seeing eye in the middle of it. Now, this is the drawing that I eventually come to, and I made so I drew the eye in there, but what you really need to do, if I'd paid closer attention before I drew it, is, you have to line up this triangle with one of these points there, and you get the eye. So there you can just each one of these little star shapes, you can just have one of those cherubs / angels / seraphim. Not exactly sure what they are, but yeah, so the 9-pointed, and you can do this from geometry. Now, that video, how to draw it, will be at the end, so let's assume we've done it for the moment. But what's the importance of 9? Now, for instance, the fruit of a spirit, as they call it: love, joy, peace, patience, kindness, goodness, faithfulness, gentleness, self-control. These are referred to, but nine's a pretty interesting number. All numbers are interesting, but for instance, 9 gods in the Egyptian Ennead. The older Ennead, I think, had 8 gods, or maybe if you include Vicent, but so 9 gods there. Now 9 muses, for instance, in Greek, Greco-Roman, and Odin was crucified himself on a tree for 9 days. He had an assistant even stab him in the abdomen, very reminiscent of another famous crucifixion. And but so 9, it's 3 squared, but Harshad numbers, as they're called in recreational number theory. So 9, so 1 times 9 is 9. Okay, 2 times 9 is 18, and then if you add 1 plus 8, you get 9. Now 3 times 9 is 27. 2 plus 7 equals 9, etc., etc. Any multiple of 9 will break down into 9. Now, even if you include, so let's say 11 times 9 is 99. 9 plus 9 is 18. 1 plus 8 is 9. So if you keep breaking them down, you're always going to come to the number 9. And that's why it's like a really cool number in that aspect. You also think, so 360 degrees, you can divide that by 9. And so, for instance, the inside angle of a pentagon is 108. That's a 9 angle. 45 degrees is the central angle of a square. 4 plus 5 is 9. Now you get, and there's plenty of videos out there, but I think anyway, I'll get to that, because the 7-pointed star, the 11-pointed star, 711, if you're familiar, recent episodes. Now they don't divide into whole numbers. You end up left with a fraction. But anyway, I'll get to that. So the importance of this. Now, the nonagon itself. So if you draw a pure nonagon, what you have is a hard angle of 40. So that's not divisible by 9 or by 3. But it's a whole number, integer. But but also 140 and 220. These interesting aspects that this in itself is very cool, because it's a 7 to 11 ratio. So 14, let's just remove the 0. 14 divided by 2 is 7. 22 divided by 2 is 11. And 7, 11, the Great Pyramid ratio, 11 over 7 is half pi. Archimedes method. And again, if you can get that level of accuracy in real world engineering, not on paper but in real world, you're doing fantastic. But when it gets to the 360 degree compass, now there's interesting connections again. So all the other angles, but I think the nonagon stands out for the 7 to 11 ratio from the inside to the outside. Now, for instance, the hexagon or hexagram, the hexagon, the inside, the beehive, etc., etc. The inside angle of a hexagon is 120. The outside angle is 240. It's a 2 to 1 ratio, that's why the hexagon is so perfect and stackable and just the most efficient use. But here we have a 7 to 11 ratio, and I'll do a little bit more on that in the future. But again, previous episodes went into that in some detail, how it's connected to the chain, which will connect here as well. So for instance, 132, let's just forget the zeros for now, 132 divided by 2 is 66. And this is an important feature because it connects to the Epic of it's just fantastic stuff, at least in my opinion. Now, so the hard angle of 40, but now these in themselves will then eventually lead to 9 numbers. So 504, 5 plus 4 is 9, 144. Okay, now, what's interesting firstly about the number 40, so again, how it so often appears in older traditions. So Noah's flood, 40 days and 40 nights. King David had a 40-year reign, 33 in Jerusalem. Jesus, 40 days in the wilderness, and after the Exodus, 40 years wandering in the wilderness. Now, the number 504, 5,040. How these, nice connections there. Plato's number, the perfect number of citizens in a city, 5,040. 5,040 is the sum of 42 consecutive primes. Previous episodes I talked about how the road width put down, especially by masons, is a 66 feet wide, but with a 42 feet carriageway, which itself then leads to pi and phi proportions, as seen in the Great Pyramid. Well, consecutive primes, 42 of these consecutive primes. Now, they're just curiosities, okay? I listen, but I think that, but they're still not even the 7. 1, 2, 3, 4, 5, 6, 7. The factorial of 7 is 5040. But and the importance of the number in 42 in especially Hermetic traditions, and again in the Bible, ancient Egypt, etc., and even in math and geometry, the magic cube, for instance. Now, if we go to the next one, so 2,400, so 40 degrees is 2,400 minutes, 24 hours per day. Again, you can see these 24, the vesica, Greek, and number of knuckles, but also the dimensions of the Earth in that long scale, which I've mentioned again, which links back to 33. Now, 130, so 220 degrees is 13,200 minutes. These old systems of measure, so for instance, 13,200 fish was like an official, back in the day before we went pure metric. Last was, and even that is another reference to the diameter of the Earth using the long scale or the Persian scale. Now 792, I mentioned that was the previous episode to this, how important it's Sun, Earth, Moon, the chain, Gunther's chain, even the speed of the solar system as best available measures, but also the Ark of Utnapishtim, or the Preserver of Life from the Epic of Gilgamesh, yes, and New Jerusalem, yes, the temples of man, as they say. Now the number, now 40 is 144,000 seconds, 40 degrees, that's the hard angle. Now I've covered this, so weights and measures, ancient one, new ones, there are 1440 minutes per day, the sun, the moon, the long foot again being key to this based on the number 33. The vesica, the hexagon, 1440 degrees being the outs, so 240 times 6, or the 240 degrees is 14,400 minutes. You can just pause and look at the Fibonacci numbers, first, second, third, and fourth dimensions. The at 12 squared being the 12th Fibonacci. Also Platonic solids, so the octahedron, 1440. You add up the degrees which define for Platonic solids, you get 14,400. Rosicrucians, octaves and elements, 144. The Baktum Mayan calendar, 14144. The Satya Yuga, which is number 1728, 12 cubed, but also that's divided into an entry, a middle, and an exit period of 144. The New Jerusalem, throughout the Bible, so New Jerusalem, the descriptions now, whether it's the area, the total edge length, the height of the walls, 144 cubits, or in the Royal Babylonian / Sumerian / Indus scale of measures, but Royal Babylonian, we know that they measured in fingers, cubits, feet, fingers and grains, 144, 144, so 12 tribes of 12,000 each, so 144,000. Same numbers are just, now back to the even much older Epic of Gilgamesh, now the tablet 11, which describes the area, the dimensions of it. Now Royal Babylonian scale again, but 144, the total edge length, 144 area. But that even converts to 144 in Royal Babylonian grains. And so again, these multiple sets of measure from across the ancient world, always coming back to these very same precise sets of numbers, and these numbers being the ones which are so important in geometry, astronomy, arithmetic, and etc. So the Nonagon, that's now I'll show you how to draw it, and yeah, so with that, I hope you enjoy and have a good one. I'll tack on this geometry instructional after this, so cheers. Instruction. Now begin with the seed of life. So we start with one circle. Now we have a vesica, so you just, without changing the compass, so there we have a vesica. Now
this first circle will be the central point, and so now wherever they intersect, I'm drawing this quickly again. You want to use a fine tip point as you can, be as accurate as you can, because every little error will be magnified as you move along. So the 7 circles of the seed of life, which will give you the hexagon, is a very important shape across nature, and from here, of course, you can the divine. Well, there's pretty much nothing here. There's so much that you can do from these very simple compass and straight edge drawings, and as what's called the seed of life. Now, this is in Euclid's, so this is not, this is pure geometry in the sense you can just call it geometry. So we've done the seed of life, which can be found in the Osiron, so many temples, across time, across the world. And now we're going to draw 3 more circles, and so that intersection, and one more here. And one more there. Now it might be hard to tell, but it's only less than a mil, but you've got to be as accurate as you can. Now this construction is not 100. It's a very close approximate of the Nonagon. Now with that, I'm going to use another compass to draw this, because now that first circle, we find the center point, and we adjust our compass to the outside there. I hope this shows up. Okay. Now in the original drawing I did, I had a lot more, so this was all filled out. So just to draw that in a little bit harder so it does show up on the camera, hopefully. Okay, so now we have the central circle, and we're going to draw. I'm going to use let's see if hopefully this will show up. But okay, so from your central circle, so from that center point, now just a drawing tip, put your pen on that point, and then you can adjust the ruler. Okay, so we're going to draw one line out from there. As you can see, we just followed that pedal. Same thing, hold it. Okay, now this so far is 100% correct. And on the laws of geometry, you know that this is 120 degrees, 120. So we've divided the circle into 3. Now, given the rules of compass and straight edge, it's a little bit tricky. Now, just to illustrate the point in reference to that Kircher diagram, so we've used 1, 2, 3, but we have 1, 2, 3 petals left. And just to illustrate that, now we're going to draw this triangle, because that, I believe, may be what Kircher was hinting at. So I thought this construction, I was unable to find it. I thought it was my own discovery. And actually, I think that maybe Kircher was pointing at this, at least, because these Hermeticists were all from the same period, but they were also in contact, many of them. And there's, so they were lots of symbolism, but they're all into their geometry. So now we have that triangle there. Now on the illustration of Kircher, a better way to look at it is like that, because at the center of his Nonagon, 9-pointed star, was a central triangle with the basically the eye emerging from there. Now, so we've already cut it into 1, 2, 3. Now we're going to, so that is, and it dropped out. So we've created this would create an equilateral triangle, these 3 points, and we have an equilateral triangle in the center. Now we're going to create a very, very close approximate of there. Originally when I drew it, I thought it was, just by logic, I thought it was true, but it's not. So, but it is very, very close. And again, this is in strict rules of compass and straight edge. This is one of the impossible drawings, because you're technically trisecting the circle. So what we need to do is cut each one of these angles into 3 equal parts, and that is impossible using compass and straight edge, strict laws of it anyway. But along that central triangle, 1, extend that out again, And same thing with this triangle. Okay, so there we have the basics of it. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this circle here, each angle. So now just to draw. So what we'll do, just to highlight that Kircher drawing a little bit better, is we're going to draw 3 separate triangles. And so this equilateral triangle I'm drawing now is a pure equilateral triangle. But now we're going to overlay, and so we've done one, and this is a true equilateral triangle. These that are emerging off this smaller triangle is a sliver of a degree off. So this is not 100% accurate, but it is a good point. So now we're going to do and skip those again. I'm getting, yep. And to this point up here. And again, yeah, shout out to Geek37. He showed he simplified the original drawing I had, and also showed that it is not 100% correct in GeoGebra, but still very close. And he does links in the description. Using GeoGebra, he can do what's some really cool geometry. So what we have is 1 equilateral triangle, 1 equilateral triangle, and with these last 3 points we fill it out, and this will give us something very, very close to, I think, what Kircher might actually have been pointing to in that illustration, because he had that in his drawing. He had these 3 overlapping triangles with this central equilateral triangle. Yes, okay, so in Kircher's drawing he had that central equilateral triangle, and just to illustrate it, he had the eye emerging from there, and he has 9 angels or cherubs at each point around the outside there. So it looks something like that on Kircher's drawing, with the 9 angels on the outside, and 9 being a very important number. Now, if